All right, so for our final activity before your practice problems on this lesson, we'll be solving just more equations, particularly equations that involve fractions and decimals. So we're going to be reviewing a lot of skills in this section. So originally this activity was something that we completed in class where one partner completed column A and another completed column B. And each row, if you were to complete both problems, they would have the same answer. So what we're going to do in this context is I'm going to go through and solve the problems in column A, and then you can use the problems in column B as practice problems. And you'll be able to check your work because everything in column B should have the same answer as the problem in the same row from column A. Okay? So let's get started. So column A is beginning with 18 equals 2x. So once again, just since we're reviewing, it's super important that we go through that process of writing every equation as a sentence, replacing the variable with the word what. So this problem, once again, is a next to notation problem. So next to notation is multiplication. So anytime you have a coefficient, a number attached to a variable with no operation, that is multiplication. So this is saying 2 times what is 18? So that can help us reason with this problem because, one, we could just say 2 times what is 18? Well, we all know 2 times 9 is 18, so x is going to be 9. But if we wanted to solve this algebraically, once again, we always use the concept of inverse operations. So if you're multiplying, but you're missing a factor, so I don't know what 2 has to multiply to get to this number, then you do the inverse division to find that missing factor. So if I divide both sides by my coefficient, 18 divided by 2 is 9, and x is 9. And then, as always, I can substitute back in to check my work. So if I substituted my value I just found for x back in, 18 equals 2 times 9. So once again, I'm substituting in this number for this variable, and it works. 18 is 18. All right, so let's work on the next one. 17 equals x plus 9. So once again, as a sentence, what plus 9 is 17? Well, I know 8 plus 9 is 17. So once again, if you can translate an equation into a sentence, you can just kind of reason with it that way and find a solution. But we always like to show work, and the only way to show work is to kind of do that algebraic work where we use inverse operations. So if I know something plus 9 is 17, if I subtract 9 from 17, that will find my missing piece, my missing value. And x is 8. Once again, we're going to substitute in to check our work, and 8 plus 9 is in fact 17, so it worked. All right, on to the next one. 8 times what is 56? So I know that 8 times 7 is 56. To solve it algebraically, we're going to do our inverse operations. The opposite of multiplication is division. 8 divided by 8 will just get me to 1x, and 56 divided by 8 is 7. Checking my work. 8 times 7 is 56, and that is true. Okay. Now, it starts to get a little bit harder once we get past those first 3 rows. So the next one says 21 equals 1/4 x. So this is saying that 1/4, sorry, I'm trying to zoom in for you a little bit. 1/4 of what is 21? Okay. 1/4 of what number is 21. All right. So now, once again, this is a next to notation problem, right? There's no operation here. So in theory, that means it's actually multiplication. So this is 1/4 times x is 21. So anytime we're doing multiplication, we need to do the inverse, which is division. So once again, that means we're going to divide both sides by 4. Oh, sorry, by 1/4. Okay. Divide both sides by 1/4. Divide by the coefficient. And so, 21 divided by 1/4. So here we're dividing by a fraction. So we spent a whole unit dividing by fractions, and we have to do that old keep, change, flip. Okay? So we're using a lot of skills here on these problems. Keep, change, flip, meaning the first number stays the same, division turns to multiplication, and our second number flips. It becomes its reciprocal. So that would be 4/1. That would get us 84. Okay, so x equals 84. 1/4 of 84 is, in fact, 21. Awesome. All right. On to the next one. 6x equals 45. So 6 times what is 45? So, once again, multiplication next to notation. We're going to do the inverse here. Divide both sides by the coefficient. And so, what's interesting though, 45 is actually not a multiple of 6. 45 cannot be divided by 6 evenly. So that means we're going to have to find our GCF here, okay, to simplify. So 45 and 6 can both be divided by 3. So if I had 45 sixths and divided both sides by 3, 45 divided by 3 is 15, and 6 divided by 3 is 2. So x would be 15 halves. So it's from here on out, it's really beneficial to write our division as fractions, because fractions are always division, and then when you go to solve a division problem and it's already written as a fraction, if your dividend is not divisible by your divisor, then you can just leave it as a fraction and simplify, okay? So this is just a really helpful way to be able to solve these kind of problems without using a calculator. All right. Let's see what else we have. I'm going to skip these ones with the mixed numbers here, and we're going to jump down to, let's work on some decimal problems, okay? So let's work on 2 17/100 plus x equals 5. So 2 17/100 plus what is 5? So once again, we're going to have to use our inverse operations to solve. So the opposite, the inverse of addition, is subtraction. So we're going to have to subtract 2 17/100 from 5. So to do that, remember, we have to make sure our place values line up. 2 17/100 has 2 digits behind the decimal, so our 5 should as well. So remember, you can always just add zeros after a decimal if it's at the end of a number. And now we can subtract, okay? So we're going to have to borrow from here because you cannot take 7 away from 0. So we'll turn this into a 9. We should also turn this into a 4. To turn this into 10, 10 minus 7 is 3. 9 minus 1 is 8. And 4 minus 2 is 2. So x needs to be 2 83/100. And 2 1700ths plus 2 8300ths would in fact get me back to 5. So the main takeaway here is just that we can use inverse operations to solve for variables. So no matter what the problem is with a variable, you just need to do the opposite operation and you can find out what that variable is. So kind of going backwards. All right, so we worked on this row, so go ahead and complete these 6 problems as well, okay? And do those independently, and you'll know that you got the right answer because the answer for x, the value for x, should be the same as the problem in the same row as it.